Hey, good morning, everybody, and welcome to Webinar Wednesday. My name is Anthony Tosi with Wales Darby, and I have Rick Costa also. He's here joining with the festivities. We have some special guests in the wing. They'll be showing up very shortly. Dean and Dennis from Electro Industries. So if you're not comfortable with GoToWebinar, you have some tools you can use. First, you can check your audio if you have any issues. Sometimes if you back out, select your audio choice again, kind of repopulates. Some more important things, we want you guys to interact, so you have a chat, and that somehow we can all get involved with your curiosity about the product, the questions. Certainly let us give you an answer on those. Also, you have handouts. Handouts is really something we'd like to share with you, so you leave with some more information or how to get in touch with us later. Hopefully everyone's seeing the first slide here, the welcome slide. It kind of points out, it says check your dashboard, and that's your that's your information stuff. But so today is February 15th, the day after Valentine's. We're gonna have a good one. Topic, why electric? It's funny, I was driving in this morning and thinking how electric seems to always been the beginning. Something else took the front, and then electric is now coming back. And I was thinking about cars, automobiles, and I think way in the early beginning of the automobile, it was really an electric vehicle. And now you think where we are today. And I'm using this product, Electro Industries, who's fairly new to Wales Darby. Man, how foreign it was, just I think to use that as the source, whether it be the cost of, KWs that are charged to your home or your business, some other factors that is just kind of like you never thought before. 2.5, 3 years ago, Electro came to Wales Darby, and with Dean's assistant and webinars that they held, and this is pretty much all during COVID, it was all about application. And then later the efficiency came, or the technology they have in their boxes, their parts and pieces. So this is a great line. I don't think we could be in a better position right now to have them as a partner. And we're going to discuss a portion of their offering in detail. We'll cover all of it, but we'll have some fun today. So thank you everyone for being here, and welcome. The picture there is an old picture, and actually if you look closely, that's me driving it. That's our mobile learning center, and that's that was a big advantage for us to get out of the classroom and bring it to local events, contractors and such. Open it up. It's fully dressed with a lot of good stuff, new technology, get people comfortable, try it out. All right, let's move forward. So there you have a couple of QR codes. It's just the way, again, technology, right? If we take advantage of it, it makes life a little easier. So the QR codes, if you scan that, is our information. Rick's on the left, mine's on the right, and that's our training facility. Before we had the MLC, we had the ELC, Energy Learning Center. It's still up and running. We try to use that as much as possible. It's the focus of any training that we do in-house. Islandia, New York is my home base, and Wales Darby has 2 locations, one in Warren, New Jersey, and one in Islandia. Not that bad. Some of the lines that you see, these are our residential offerings, but we do more. We are on Instagram. We'd like to share and get to know you guys. We do a lot of stalking, if you want to say. So we get to meet a lot of new contractors because of what you guys are sharing out there. So get involved. Here's the locations, Islandia on the left, Warren on the right. We do have a Philly office, but not a footprint. And again, a little bit more of an offering, and then we expand out more commercial. So Wales Darby, sorry,
30 lines, I believe.
Yeah, I would say we're growing. Wales Darby's just over 50, just about 50 years, third generation, similar to Electro in their birth, 1973, 74. So they have some lineages. It's moving forward. So we have Dean Pavel and Dennis Schrammel from Electro. I hope everyone can see them, and we're going to get them to partake in some of this stuff here. In your handouts, if you look in the lower right, you'll see I put a little arrow and I put a little go to, and that's one of 5. So if you look at your dashboard, this is one of their brand new catalogs. So I wanted to make sure you guys have a copy of that. And great job on that, guys. I know you guys have been working hard. We're trying to upgrade some of the look of Electro. So how long did this take?
I think it didn't take too long for our marketing company to create that, but it's an ongoing thing because we got a lot of products, a lot of diverse products there. So
Sure.
we're chipping away at the catalog, and there's some other stuff, electric boilers that are done, and makeup air packages that are done as far as literature, and then we'll collate all that into one catalog. So it's a work in progress.
Hey, Dean, while you're on the horn, and I know Dennis, I'm sorry, Dennis and Dean, I'll get it straight. It's like Jan and Dean. Dennis, tell us about yourself. How long you been doing what you're doing, whether it be where you are currently or industry-wise?
So I've been with the Electro Industries for nearly 5 years, and I'm the national sales manager. And I have a background in the electric utility world for about nearly 30 years, and always around the world of hydronics and radiant floors. And I've helped distribute electric boilers for Electro Industries long before, probably 25, 30 years ago. And it just kind of manifested itself into, staying in this. It was kind of my wheelhouse of hydronics and heating, and I was lucky enough to come and make it on board with Electro Industries back in 2018, and it's been a fun ride. And my responsibilities, I just we set forth the goals for the sales reps across the country to achieve the company initiatives set forth. So thank you for letting me be here. Appreciate it.
Oh, of course. I don't think we'd have it any other way. So. Dean, yourself, I mean, we've spoken on the phone. I've seen you on webinars. I kind of looked at some of the history on the website, but I've not got a chance to meet and be in person. So it's nice to have you here this morning. Always been great to talk with you on the phone.
Yeah, I appreciate that. Yeah, I've been with Electro now, I think it'll be 22 years coming up in April. So kind of started, my dad was a service tech, so I kind of started out when I was pretty young holding the flashlight for him, and
I love it.
The industry for a long time. So electronics background, technical, but I kind of do a little bit of everything at Electro, really focus on the training, the sale, training, troubleshooting, sales, tech support, stuff like that. I help Dennis wherever I can, and it's been fun. It's been awesome getting to know you guys. I mean, back when I started Electro in 2001, we'd get a call a year from the New York market about a boiler, about something, always really kind of one-off thing. And then, 5, 6 years ago, Dennis and I were looking at it saying, man, we got to do something out there because this is going to hit. And this has been a great start to hopefully a long relationship.
Yeah, absolutely. Like I said, I think I don't think it's a better time to be right where we are right now. And I wanted to ask you something, and maybe you can clarify, as much as you touch this, every day so much. Is it electrification or decarbonization? How do you feel about those two words? When I talk to people, man, I was struggling to say, people have their torches and pitchforks, and they're ready to do rumble, when I say electrification. So I don't know. I have my reasons why I like to say decarbonization. I just wonder what yours.
I mean, for for me, what I see is the push for electrification, decarbonization started, what, 3-4 years ago. And it just got people thinking. And really what I run into, I think if I get a call from Long Island, a typical call for me from Long Island would be, I got this oil boiler. I'm tired of filling it with oil. I'm tired of this messy old thing in my basement. It's 15, 20 years old. It's time to change. I've heard about electric. What can you tell me about an electric boiler option? Is it going to be perfect for them every single time? Is it going to save them money?
Right.
Yeah, it's safe, but it's got people thinking.
Absolutely.
For me, the challenge has always been, I can talk to them blue in the face about how great electric boilers are, but until they have that contractor walk in the house and say, look, I can do this, we can do this, this is what it's going to cost you, this could be a great choice for you or not. Some people don't care what it's going to cost. Some people will say, my heating costs are going to go up by 40, 50%. I don't care. I want this oil out of my house. I'm tired of it. And like I said, the beneficial electrification, the electrification movement, it's out there, but it's got people thinking. It really does.
Yeah, I think that's the winner for me. And watching the webinars you guys offered over the last how many years during COVID, it was all about application. And just for me, it just started clicking. It makes sense. It makes sense. Because I deal with a clientele, like you said, maybe the money isn't so much the issue because of East End, but they just want to be off fossil fuel. Literally, I've heard that many of times. I just want it out of my house.
Yeah,
And
I
I've
think,
had contractors. I'm sorry.
Yeah, beneficial electrification has so much, benefits of it, with,
Sure.
you hear that term, you hear decarbonization, you hear degasification. It's all, it's either governmental push there to lower greenhouse gas emissions. It's a push to utilize the renewable side of solar and wind and tying those in with electric heating products or electric products in general. Because gas will never work off renewables, right?
Right.
And so there's that portion of it that is going to be a big push of beneficial electrification. And there's a side note to that, is that electric is there's no flue. You can install it anywhere.
You're stealing my thunder.
Yeah, you got some
it.
value points there. So in degasification, you got a lot of areas throughout North America that are just getting rid of natural gas and go to the heat pump movement, but it's not solely heat pumps only. So northern markets, you can't work with just heat pumps. You might need some assist and stuff like that. So yeah, there's a lot of benefits to electric and electrification.
I just like the conversation in general about electrification and how everybody freaks out because we do this every so often. Right.
Yeah.
We did it when we were oil guys and they started telling us we were going to do gas and everybody freaked out. Everybody, mother is out there installing combi boilers like they're nothing. And it's every couple of years you get a product that we're told about and everybody freaks out and now it becomes the normal.
Right.
Yeah, and some of us live in a bubble of going, okay, electric's expensive. Well, it can, but in general, to what? To what propane, what oil is, and what natural gas is. And so that's where we help come in and educate you guys, educate people downstream to kind of going where that is, and then how we bridge that gap of value of electric, that where homeowners, contractors are looking, hey, this is not, there's a very little delta between that and my existing oil boiler, for example.
Agreed. I brought this up to kind of poke the bear a little bit, and not you guys, but that, like Rick is saying, you start to get people's emotions going when you start saying something different.
Change.
Yeah.
It's a natural thing.
And we've seen this in my time with Wales Darby many times. And that's where we are the forefront to bring things, rub the opposite direction sometimes, and I think this is a great benefit. You just hit one of the biggest thing in no flue. Flue is liability in my book. I've seen it wrong more times than I've seen right. And that's a huge thing in people's homes, let alone, and thinking the client when I work out in the East End, they don't want to see it. And this is now a big struggle for installs and how to do it right. And that's why usually it's installed wrong. And I like a lot of things. about what we're moving with the two products that you see on the screen. Heat pump has been one of those other things, a refrigerant based, it's the end all be all. I've seen so many things misapplied. And anything we do going forward with technology, it's sizing and selection. You got to understand that I might not be able to do it all, but I'll work nicely with others, or I'm going to take it so far because of refrigerant restrictions. But then you got to be honest. It's not oversizing it is the king anymore. You're going to shoot yourself in the foot. So why electric? I ask, why not electric? Dennis, you hit it. What isn't expensive? You know, where we are, electric, yeah, people, they'll tell you how expensive it is. I'm like, yeah, so is every other fuel you have, whether it be in your car or your home, you know. So today we're going to talk about, in details, you know, as we go back and forth, a little banter, our heat pump boiler, which I think is huge for us, and the electric boiler, of course, and all that it offers. And of course, there's more. All right, so this is the more. All right, we're going to focus on the NorAir, and we're going to focus on the electric boiler and the EZ package boiler, which I think is great. But we do have other products, and I learned about a few things, and I said, wow, that makes sense. And one of the most eye-opener was that electric duct heaters, and the simplicity of it, and the controls to take a room that isn't being heated because of this central system. You put this in line, it's passive, you're using a fan from by others, and now you have this heater coil. It isn't a light switch. So you guys offer this technology, which I want you to kind of explain what is warm flow.
Well, yeah, so what warm flow is, you know, the word kind of alludes to it, warm flow. It's just a method of controlling our elements to maintain a constant temperature. You know, the application you describe is a good one because, you know, let's say you have that room, maybe it's a porch that's converted into a bedroom or a space that just never gets warm enough when it gets cold outside. And so maybe the ideal would be we need to deliver at least, you know, 100-degree air to the registers in that room if we're talking forced air, right? So on a 50-degree day, your furnace can deliver that temperature to that room all day long, no worries. But when it's 25, it's going to struggle. That's where our control can say, okay, I've got 80-degree air coming in. I'm going to bump it up to 100 and maintain temperature leaving this device to go into that space. So just a precise way that we can control air temperature in that duct without, you know, you might put in let's say a 5 kW heater. If we only need 1 kW to bring that temperature up, or 500 watts to bring that temperature up, that's all we'll use. So we're kind of maximizing the efficiency of that product by not always just going full blast. I mean, anytime I think about electric backup for a heat pump system or whatever it might be, they always think, oh, it's got to be all on or all off. Just flip a switch, flip the backup on and let it burn. That's not what we do. We say, and we've been doing warm flow since the 90s. This is not a new concept.
Yeah, your website is full of information, you know, and I read about 1973, you guys are doing gas-fired makeup air.
Yeah.
And I was like, wow, I didn't realize how far back you went back with makeup air.
Yeah.
So two things.
Yeah, that duct heater is such a easy system there to bring, you know, comfort and efficiency for a homeowner. I mean, it's not just limited to residential applications. It could be commercial applications as well for office spaces along windows that need a little boost of heat. Very simple to slip that in there, and it's yeah, you're going to run more, run a little bit of increase in cost of electric heating, but you're getting comfort out of there.
Yeah.
Billy and Johnny's room over there in the basement or something, or in the far reaches of the furnace, that you're increasing comfort in there. And that's just a nice, simple, easy system to use.
What comes to mind is a solution. Do you upgrade the whole system to give more, or you just add this as a little, like a boost?
Yeah.
That key thing there, that middle line there, modulating heating elements, and that's that warm flow. It's not a light switch. So that's where I think a lot of people have this thing about electric and where we're talking 0 off on at 100, and that's not the case. There is efficiencies in your technology and how you guys develop the products, which is really cool.
Yeah, just a quick note, an application that we saw out in your area about 6-7 years ago. They put geothermal in for a assisted living complex. I think there's about 100 units.
Okay.
And you know, when you have people in that kind of facility, some like the room warm and some like it a little cooler in there. And with geothermal, you know, you get those shoulder months where we could be struggling. So they put one of our warm flows in each space, in each apartment or each building area, and just let them control that air temperature as they want. They said the geothermal doing 90% of the work, but if they need just a little more, they gave them that little electric heater, the inline heater to boost the temperature to where they want it. So
yeah, we'll get into a little bit more, but just to say, starting here, as simple as it is, man, it has a lot of little added here solutions. Just get comfort into people, like you're saying. And just to paint a picture, there's a sensor that you would put in the space, and it's trying to maintain that temperature, whether it be what's existing, and it can't, now it kicks in the element, and that starts to drive that air temperature up and delivers it to the space. So flat lines when it satisfies and turns off. Neat stuff. Now, the biggest thing that I stepped off because of what we're selling in the territory was the package makeup air. It's packaged, it's small compared to others, and it's complete to satisfy a code requirement. And correct me if I'm wrong, exhaust over 400 CFM in the building. Buildings are being constructed tighter and tighter, multiple bathrooms, central exhaust fans, multiple dryers, 6 burner range with, sorry, I gotta get power. Right back. Thank you.
Yeah, you got the exhaust fans of,
Otherwise, we're gonna turn
these
off.
big roof ranges that are in homes that
Notice that doesn't actually quite hook up. There you go.
gives way to needing some type of balanced air.
right.
I'm sorry, just to get back, my laptop is gonna go bye-bye. Yeah, but the package air was something I found with a lot of the larger homes. Probably nobody cooks in there, but they got the stellar kitchen and the 1,000 CFM hood that they're gonna turn on to smoke a cigarette. So they're gonna create such a negative pressure in the house that code guys have really been pushing makeup air, which is great.
Yeah, it's a safety factor too, right? I mean, because if you're
100%.
depressurizing a home, and you got a lot of gas, oil, appliances there, you got a risk of that backdrafting down, or either short cycling, or not firing at all, and worse, carbon monoxide issues that could be prevalent of that. But this thing is just a sweet deal with guys who, it's a code issue in some aspects in parts of the country. But you're seeing more and more contractors and homeowners doing it because they want a healthy environment and a safe one. And this just provides a nice, easy package, labor saving compared to competitors offering.
100%. I mean, just to say, it's not small to the scale of our 1,200 CFM. It could be upwards 4 feet. Is that fair to say? But by others might be upward double, 8 feet, if you put all the components together. That's a lot of space in a house that maybe you don't have, and now you've got to fit it. So this is a solution just in the approach of packaging it.
Well, yeah, you're seeing
filter, heater element, anything below 50, I believe, boost it up.
Yeah, you're seeing the shrinking mechanical room, right? These houses 100%. Are built in, and the mechanical room is just is getting smaller and smaller. So this fits in there versus competitors offering, like you said, I call them bazooka models that you gotta put them all together. They take a great deal of space and time to put them in and controls. And this is just a nice labor saving solution, a nice aesthetically pleasing solution for a homeowner.
And not to go too deep, but the technology to see what your exhaust rate is at an appliance. That's huge. That's like candy right there. That's CT technology, having the ability to see the high, medium, or low fan, or what's going on at dryers, or anything, turning a light switch on for a fireplace, just to put a little makeup air to make sure draft and smoke leaves the building. So there's a lot of cool things you have inside each one of these products. This is also part of one of your handouts, so please grab that. And the last thing before we get into what we're really here for, and I'll say this, we don't do a lot of hot air, right? So we do some HVAC, but to say the electric duct heater, if I give you an application and conversation, I have a solution. Backup makeup air, and then also the electric plenum. Now that's something I don't really come across hardly ever for where we are. Now it's out there, different rep, different clientele, I don't know. But I like the idea, the warm flow, again, this electric boost to bring air temperature up. You know, there's efficiencies in it too, not a light switch. 0 off again, 100 amp. So
Yeah, you're in a predominant, hydronic market with radiators, but this system, it gives the homeowner choice of fuel to use for those who have maybe propane or oil furnaces. Now you have a choice. You're not locked in one fuel type, and you got $4 to $5 per gallon oil. Here's a homeowner is in charge of their fuel, who they want to pay at any given time. And then you got, the warm flow wrapped around it to take advantage of heat pump technology and boost temperatures as needed to maintain comfort. And that's what we're all in. We're in the comfort business.
absolutely.
This happens to be electric heating products is driving it.
Yeah, I think there was one thing you said there is key, giving people choice, redundancy, Right? They might have a deficiency and there's a solution, but now everything's expensive. I can pick and choose when. PV now on a roof is becoming very popular again, so, but your lineup it's a lot of different areas, but it's complete. I love it. I like working with you guys on this stuff. I'm learning every day. On the left-hand side, you'll see NorAir, air to water heat pumps. And this is one of those things, like you got to wrap your head around it and really find, man, I can do some damage, some business with this. And because of what's important, and people have been so embracing air source heat pumps. So now we have this familiar already, point of direction, and we're going to add to it. We're going to add something that we all have to understand. Refrigerant has a limitation. It can only take you so far. And where we live, and certainly where you guys live, it's cold. And sometimes we will not be able to keep up solely with a refrigerant base. So we have the backup, which is the other thing you guys do really well, is an electric boiler. Then there's technology, right? So again, what isn't expensive? Electric, yes, there's a cost to everything, but now we have solutions. We can do this, refrigerant, 80% of your heating season, really, really good efficiencies, and then only use for a boost or maybe take over the electric boiler portion. And that's a very short window of time. And then obviously as another option, there's an existing system in the house. We can play nice with it as well. So we have a scenario right now, and we're talking to the contractor as we have conversations. He's got a project. They want to know if this works in tangent, simultaneous with the existing system. Is it heat pump, electric boiler, and fossil fuel all at once? Or heat pump to a certain point, then our electric boiler, and then simultaneous? What do you think about that?
So what we typically, you're never going to run electric with gas at the same time. So the scenario that we run, the scenario that we, program to or design to is, like you said, maximize the heat pump. Let's get everything out of the heat pump that we can.
Sure.
it might be an application where we've sized the heat pump just right that down to 30 degrees outside, the heat pump's giving us 110 degree water. If it's a radiant job, perfect. We don't need any help. The heat pump's cruising along at 250, 300% efficient.
Right.
We're fine. Then all of a sudden maybe we drop temperature. We're down in the 20s. Our control is saying, okay, you've told me you want to maintain 110 degree water for this floor. The heat pump's giving me 100. We're going to bring out electric elements to get it to 110. So we'll modulate in an element. We'll just boost it. That warm flow technology, we're just taking what we have from the heat pump and just bringing it up to that comfortable temperature, whatever, really what you decide that should be, because everybody's different. Every application is going to be a little bit different. So we give you that flexibility to pick that temperature that's going to be right for this job. So we'll modulate up. We'll be cooking along with the heat pump and the electric, and then maybe we just get to that point where, okay, it's down to 0. We haven't really sized this heat pump electric to really handle the system at 0. We're going to shut down and we're going to fire up the gas back up or the fossil fuel back up.
Right.
And so, it's either or with the electric or the gas. Typically, we're not going to run both together, because what can happen is if we've got a lot of BTUs in the gas, if we're running, all of a sudden we fire on 100,000 BTU fossil fuel backup, it kind of overpowers our system and it kind of takes over anyway, because all of a sudden we see return temperatures coming up and we're saying, well, we didn't do anything because the return's coming up. So it kind of naturally takes over anyway. So in the interest of keeping things under control and not running into limit issues, it's one or the other.
So I had something in the highlight there, 2 parts free energy, 1 part electric. And I think that's air source or air to water is,
right.
Trying to draw that outside air. Even in -degree temperatures, there's heat energy still that we can utilize into refrigerant base under compression and make heat and deliver it now to a medium of air inside or for coil or water. And once you have that water and you build enough bank, a buffer tank or something like that, man, it just becomes hydronics 101 again, which we've been doing forever,
Yeah.
And I think, again, sizing and selection, you're going to hear me say that, because there's later something in this presentation, it's the baseline for anything we do, because technology will bite you if you don't play nice and read the manual, in which exactly what are you going to get out of this under design conditions, and that we don't want, because whenever it fails, it's a product issue, right? So we live in that world, and I don't know, I have different opinions about that. We do plenty of trainings. It's a little bit of time, but the investment will show rewards. So we'll talk about NOR in a minute. And then on the right-hand side, you talked about mechanical rooms shrinking and the EZB, or the packaged electric boiler, what you guys have done with that. Man, when I saw that, it's like, this makes sense. We have issues with talent in our trade. Young people, are really gravitating towards the trade here, and this makes sense. This is a moneymaker if you see it for what it does for your time management and scheduling and just supply chain stuff. I don't know how well you guys are pushing this stuff out, but there's a lot of components, and we'll get into that a little deeper. And of course, your lineup up to 1 million BTUs, on the electric side, and you can build it or you can buy it, with the package. So it's your choice. So.
I got a question just to Dennis and Dean real quick. What are you guys seeing, I guess, now territory and others, as far as the electric boiler or more the heat pump with the electric boiler? Which way are more people gravitating to?
Without question, it's the electric boilers that has the bigger push there, and by wide margin. But I think it just comes down to contractor awareness of air to water technology, and it has its limitations. It's not a catch-all for all high temp baseboard fan coil type of heating. It's all low temperature radiant floor, so it's got to fit into that pocket. But it's really emerging technology that is gaining ground, not only throughout North America, but over in Europe, they have hundreds of thousands of these installations out there. So yeah, the future's bright on air to water systems.
Yeah,
That's
I would.
great.
Yeah, definitely. Dennis hit it right on the head. We have pockets, of the country where mild, the coldest day or the design day is 30 degrees, and there's guys that they put in nothing but Nor'air systems for all their hydronics. But it took them a while. They had to get comfortable with the system. It took a lot of hand holding, which we did, and once the first one was successful, that brought on a lot more. But yeah, with the ease of the electric boiler and the way more applications, that is definitely, we see a lot more of the electric boilers.
Awesome. And for the chat there, we got a good group today. I mean, you guys want to throw, are you guys currently doing electric boilers or air to water? Love to hear from you.
Absolutely. I don't know, where's everyone coming from today? We always ask that as well. Thanks for joining us. Where are you coming from? This slide is kind of like, I ask why electric, and then we discussed, and I go yes to electric. It's another option because of a lot of different variables, different job sites, different scenarios, different requirements. People want what they want. Dennis is famous for saying they want gluten free, give them gluten free. Right? So
I stole that from Dean for the record, and now you called me out on it. Yes.
Oh, that's great. That's wonderful. So not to read every line here, but I highlighted, and I wondered which one would you pick top three? What would your top three be? Efficiency, simple, reliable, like what would you say, pecking order wise?
I mean, I think safety has such an aspect, for the family, and I think any product out there, it has to be centered around being safe. That'd be my top one. Efficiency, of course, we're trying to either offset heating costs there. Efficiency comes to mind. That would be my number two. And of course, you got to have reliable products there. You got to have products that are going to handle and stand the test of time. And we've been around since '74. We are still making components for boilers that are 35 years old and still supporting the industry out there and the homeowners and downstream. So I say those are my top three.
Very cool. I was simple, efficient, and reliable. I think from the contractor's mindset, I'm always with the end user. But if they understand it, it's repeatable. Again, it's going to roll down to the end user, and longevity, serviceability. And the Made in USA is probably my fourth for me. That's why I put the flags in there. So.
Yeah, for me, I think the simple installation. It's like you said, if you make it easy to install, the contractor is happy with it. It's going to be. He'll do another one reliable. Once you put that in, you don't want to have to worry about it. Maybe you set up I get a lot of guys that say, what do we have to do for an annual maintenance check? And on electric boiler, it's visual. I mean, check your glycol, but there's no flue gas to check or adjustments or anything like that. You do
liability.
A few basic checks and you're good to go. Peace of mind to that contractor, peace of mind to the homeowner for sure.
I agree.
For me, Made in the USA, I think would be third, just because we're, the electric boiler world is, we've been in it for a long, since '74, but there's not a lot of other U.S. made electric boilers out there, mostly made in Canada, coming over from Europe, or if they are made, they're, produced in Mexico or abroad. So we're, full assembly right here in Monticello, Minnesota. We obviously don't make the steel or the electronic components, but we bring everything together and we do all the work here, and we're proud of what we do. So
I'm proud of you as well. Thank you. That's great stuff. The one thing that caught me on this safe, clean, and quiet, because of where the opportunities allow us to put a mini boiler for a small radiant area. I want to do hydronic radiant in my bathroom, a little crawl space. Crawl space is the bedroom. There's no fan, there's no issues with venting, and all the safety stuff. So there's little pockets on every single one of these bullet points that really are the storyteller to why electric is something we need to pay attention to. Neat stuff. So where does it all start? Sizing and selection, you heard me say it. Heat loss. We got to know what our loads are. We want to be efficient, because the biggest thing I always get, well, what size breaker and my panel and whose house is wired. I mean, you hear the negativity before they even hear the story. But when you hear the story, well, we can do some things to fit in that panel, service panel, if they're not going to upgrade it. One is maybe it's partial load. Maybe we're not going to do a full replacement. We'll play nice with others. We have additions too. How about lowering water temperature? Really understanding what the building's load is. Because now all of a sudden that changes what model of a unit that we need to install. And then we can play nice maybe with the panel again. Again, full load or 3/4 partial. Who knows? All right, so this has been forever and ever. This is Wales Darby's mantra. You tell me, hey, what size room, what size boiler do I need for this 2,400 square foot house? I'm like, I don't know. Is it a house made out of glass? You know, tell me about the space. What's the BTU load? And then you get all this, you know, frustrated. But this is the crux and the downfall of most of our industry here locally. They don't want to do a heat loss. And I think rebates, things are starting to grow and get people's attention that they're going to have to start and do it correctly. Because again, I think there's liability. I jokingly say anything that ends in your honor isn't a good thing. So when you get pulled into a court because people are unhappy, you better be able to prove why you selected what you did. So Manual J, all the things about the building construction, it's not that hard. We break it down pretty simple, and now it's you know, it takes liability away as well, and estimating. So room by room, and then you build your emitters, and then you build your source, and that's protection. That's protection and guaranteed comfort.
This isn't just an electro thing.
No.
This is every appliance you put it into somebody's home.
So having a one room, think about it, I always use as an example. It's a 10 by 15 room, baseboard, you know, how many feet of baseboard would you think? So I did a heat loss, and where we are, it's a 15-degree design day, and a 0 degree for something further north, Concord, New Hampshire. And you can see there's BTU load requirements differently. That's an hourly loss. On a design day, by doing the math, we're going to see we need 4,000 BTUs to keep someone happy at 70 degrees. Right? So we take consideration of the space, construction, above, below. There's programs out there. Manual J has been around forever. And again, this is something, if you haven't, you might have to. And I'm telling you, it's the best way. It's the only way I do a design. I will not be part of a request to offer radiant, let's say, on a guess, because it always comes back to bites, and then I get pulled in. So not comfortable.
Did you decorate that room yourself?
Yes, I did. Skinless cat, or hairless cat rather. Drum set. Sure.
Great.
I'm surprised Dennis didn't come in first.
You know, being nice here so far.
I'm surprised the bed is made. So.
Yeah, it looks good.
So the magic number, if 15 feet of baseboard at 180 degree water, you're doubled plus what's required for a 15 degree day where I live. So 8850, 180 degree water, 170 average maybe, you're way overheating the space because of the emitters. So now we have the advantage to reverse that And when you reverse and start lowering water temperatures, electro and the size in the panel, it starts getting smaller and requirements. So that's why I wanted to put this in here. So big or small, you got to do a load, right, going forward. So if we took this space, every room, it's 31,930 BTUs. That's on a, let's say, a 0 degree day. Now, if you don't trust that number, because a lot of people look at it, nah, that's way too small. I'm going to go bigger. Bigger is better. And then they start short cycling. Everything becomes more cost to use it, to run it, you know. So we can reverse this very simply, doing one step different, doing it, do the math, do heat loss. All right, so BTU is what we deliver, not heat, not temperature of water. Temperature of water determines our emitters output, BTUs. So BTUs, what is it? Right? Amount of energy required to raise a temperature of 1 pound of water, sea level, 1 degree Fahrenheit, and reverse for process cooling. So this is nothing new. We use BTUs all the time. I don't think we quite understand what it means. So British thermal unit. Funny story, I had a big trainer, sorry, North American well-known trainer for TACO. He did a course over in UK, and they don't even use BTU. They use, I forget the unit they use. But it's funny, he's like, how come you guys don't use it? It's named after you. Yeah, they didn't have an answer for him. So that's funny stuff. Yeah, so I like just getting people to think of it. What comes to mind when you hear low temperature heating, right? So I'm asking you to think about lowering water temperatures to deliver more efficiency. It sounds weird, but it's possible. I prove it every day. Because if I size and select based off of loads, you're gonna win. So radiant is funny how it's okay, we can lower water temperature here. But man, it's just, anything else? No, 180, 190. Burn, baby, burn. Right? So here's phase 4.
A lot of benefits of that low temperature water, if I'm interject, you know.
Please.
You're hearing from, you know, the godfathers of radiant heat, you know, these big gurus like John Siegenthaler, and we got to think about the energy side of this too. I mean,
100%.
talking about the pumping capacity, and of course we got ECM driven pumps here now, but if we can lower that, we don't, you know, we can save energy as well.
Absolutely.
So at lower water temperatures, that's something to keep in mind too as we move towards this, the water systems.
And that's where I'm saying, I'm tying in with the negativity of electricity and maybe what the product that you and we sell offer, but they right away think they can't do it. It's going to cost too much. And you got to build a better, you know, approach. And it's always been this, you know, a load, a design, heat loss, and then lowering water temperature for anything. It could be for condensing boilers, but no different for what we're trying to provide in using less energy, but deliver that comfort. So using that 1 bedroom, 15 foot of baseboard, here's a chart for baseboard and showing you BTU outputs when you change water temperatures. So if we do the 180, there's our 8,850, way more BTUs than we need on a design day, which is less than 2% of any heating season. So we have 98% of being uncomfortable because of our emitter output or short cycling a boiler that's grossly oversized. You know, we're going in the wrong direction. So if we took the 180, which we really don't have in the middle or the end of the loop, the zone, we want to average. So let's say 170, high temperature, we're delivering just under 8,000 now. I need 4,000 BTUs for that 15 degree day. How low can we go? Well, there's that 130 degree water temperature for a very small portion of our heating season. And that delivers just over 4,000 BTUs, right? And again, imagine going back to a boiler now, taking all my room by room by room, building the load zones, and now I have my source, you know, and it's really cool to see those numbers kind of work in our favor, not against us.
Sounds like ignoring our application.
It does. So what is the lowest water temperature you have on a radiant job, right? So again, the comfort level, I'm trying to bring people back to, oh yeah, I do comfort. I do radiant all the time. Sure, so I've done 110, 120, 130. Again, why is it okay here, but any other piece of equipment, it's got to be pegged. Aquastat is all the way up, right? Make your awareness of different products to marry with sources that are labeled high efficient, that aren't installed in high efficiency situations, or energy hogs, which we don't want our product, Electro, to be labeled as. So we can do all these options and still deliver great comfort with efficiencies. Neat stuff. Lowering water equals high efficiency.
So maybe just based on that load count you were just doing it with that room, and we talk about some of the micro zoning that we're dealing with. We got some good questions here from our friend Jeff regarding the indoor air. You know, he's noticing the smallest unit we offer is a 3-ton system. You know, so he's asking about buffer tanks. You know, and I think we always, when we talk about micro loads, we're always talking buffer tanks. He's also asking, is there a possibility of getting a smaller unit, 2-ton? Your thoughts there?
Yeah, I mean, we're actually in the process right now of looking at smaller units or designing a unit for smaller applications like that. You know, it's a little ways off. One of the things that we're starting to see implemented a lot more is inverter heat pump technology. You know, so now you've got you know, when we talked about a 5-ton unit, you can use an inverter that'll go from 4 to 5 tons or 3 to 5 tons. And then when you have a 3-ton unit, it might be a 2 to 3 ton inverter, which will work just fine with our indoor units, with the way our coaxial coil is designed. So we can get down there with the inverter heat pump technology. You know, some of the different brands out there that are not the full communicating, but the standard, you know, 4-wire communication, working pretty well. Buffer tanks, yeah, absolutely. You can use, you know, if a guy likes to use buffer tanks, you know, we don't necessarily have to use a buffer tank in every application, but some guys like to, and it works just fine. Hydraulic separators, just to keep maintain nominal flow through the coil, is another good way to do that without worrying about any kind of short cycling. So yeah, those are very, very doable. And yeah, like I said, we are looking at a smaller, you know, kind of a redesign of the whole product line as we, you know, go into the future, and that will include, you know, the capacity going down to smaller capacities for sure.
Very good. I think we got one more question here from a couple guys, same topic here. You know, how friendly are we when it comes to DHW, you know, indirect water heaters? Any thoughts there? That's popping up.
Yeah, yep. And so we haven't quite gone to the point where we're saying we're a true heat pump water heater. We can do a good portion of the water heating on an indirect water heater tank. The limitations become the water temperature itself. As you drive the tank temperature up to safe water temperatures, that higher return water temperature is what affects the heat pump. The heat pump basically says, well, you're not taking the BTUs away because you're sending warm water back.
Right.
So if it's an inverter, it just starts to slow itself down. If it's a standard heat pump, pressures go up, and then we start to lose efficiency. We're monitoring water temperature, both the inlet and the outlet. We're actually monitoring refrigerant pressure. And a lot of times what we'll do on a domestic hot water is we'll finish it off with the electric boiler backup. So you might have, you know, the first time you heat up that tank, the heat pump's going to do a great job of, you know, doing 80 to 90% of the work. But then to bring it up to safe temperatures, we'll probably finish it off with the electric boiler backup. So, you know, we've got people doing it with good success, but again, it's something we have to think through and make sure we're doing this right. And like I said, we haven't gone as far as saying, yeah, this is a true heat pump water heater, but it's definitely can really take a bite out of that hot water load, especially if they have a big demand for domestic hot water. They don't have a very big demand, you know, if they're just running a 30-gallon indirect for one bathroom, you know, there's going to be some benefit there, but you'll probably end up using electric boiler more for maintaining that tank temperature than you would the heat pump.
Very cool.
Yeah, I might add that, you know, of course, our electric boilers are capable of that high temperature output,
That's
either
right.
stepped up to 150 or 180 degrees, and you know, still be able to do low temp 120 degrees. You know, basically we offer zone controls that can get an input signal on a priority and step that boiler up to a high temperature output. So it doesn't matter if it's a residential, commercial, industrial boiler, we have that technology built into our controls.
Dean, sorry, Dennis, we had conversation over cigars and scotch about Doc says hello. I don't know what he meant, but you know, he asked about off the doc, but your orthotics.
I missed the guy.
But,
That's funny.
where was I going? PV and different utilities with banking, and then you spun something on me about why electric boilers made sense for certain people, especially with maybe where we live. We offset our monthly, and we get a small portion in return to what they charge us for. So I want to maximize the roof investment or the PV, and I want to use as much as I produce. And that made so much sense to me. And I don't know if the utility is going to change and allow banking or doing more programs. I know you spent a lot of time, you know, in your career and maybe even building those developments, but I see that as a bright future if that works.
Well, like Dean said, you know, we're seeing all the, you know, the calls that come in from that East Coast area in New York, all along the seaboard, you know, it's just the push of PV systems. Yeah. And they're collecting all this, you know, it's called net metering is basically how you can bank these kilowatt hours because you may not be utilizing them in real time in the summertime because you have more of electric or a heating load in the winter time. So now you're banking all that only to draw from that later. But some of them, if they have oil, gas, you might be giving them credits and getting a fraction of that energy back because the utility companies aren't in it to just give away free energy. They're making money for a reason, right? So it's a way for a homeowner to take advantage of their PV system and utilize to offset the electric consumption out there in kilowatt hours. So
Makes
perfect
sense.
marriage.
Absolutely. So talking about kilowatts, and this slide is just for you, Dennis.
I know, you're wrong.
Yeah, whatever, the internet. So I jokingly ask, because it seems to be about temperature with any BTUs, like, you know, how hot is a kilowatt? You know, and it's kind of like a trick question. The kilowatt isn't hot, right? It's a BTU content. So let's start understanding we deliver BTUs. And now with this new technology of electricity or electro industries, we build everything around kW units, right? So if we understand what our BTU loads are, man, we can fit the bill. We can play nice with technology. So 3412, 1 kilowatt equals 3412. And we did that total load for that space before, doing the math, just under 32,000, about 10 kW. That's the size system that would carry the load of that space, right? So that's that simple kind of approach. Now we're dealing with kW, BTU conversion, 3412, right? Sorry. Something got frozen here. There we go. All right. So let's get into the NorAir. NorAir is a great product. Man, it has a lot of things in a small package. You can do heating. I don't know if you want to go there today. We can do cooling. But this is a traditional heat pump condenser line set to a coaxial coil, which now transfers that energy into water, hydronics, in which we can do the electric boiler backup. So the model I kind of highlighted here, the HPH 3-10, 3-ton hydronic, 34,000 BTU with a 10 kW auxiliary boiler. Now, at some point, we're going to run out of refrigerant, meaning it can't deliver the comfort. So we need to have that backup. Now, whether we use the onboard boiler, or maybe we play nice with an existing, whatever, fossil something or other. So NorAir is the brand or the model number, and 3193 was the load that we needed. The efficiencies, though, using that heat pump has been proven. It's 2 parts free energy, outside air, with the boost of compression using electric, right? So we have compressors creating that refrigerant. We got heat. Yeah.
Yeah, and I would kind of take note on that, you know, the 2-to-1 ratio there at 200% efficient, because you and I've talked throughout the year, and you know, you're at 50 degrees out there on Long Island. We're sitting at what, 18 today right now. So obviously there's more heat content in that air at that temperature. So in your market, you know, Long Island, in the surrounding area, you could be up to 2.5, you know, 250% efficiency, maybe a little bit more than that you're pushing, without question.
You know, I think about other products that we represent and love all my manufacturers, but with anything with a flue, you're already in a negative with efficiency. Even if you set it up the best you can, a lot of guys have to say, don't do that. So it's more of a space saver approach. And like you said, the mechanical rooms are shrinking. But now this thing, really, what are you setting up? You're not doing a combustion analyzer, you know, an analyzer. So this is out of the box efficiency. Sizing and selection, right? Do a load, come up with your base, and go out to the house. Neat stuff. This is what the coaxial coil looks like, right? And a little snapshot. What is this indoor, outdoor? How does it look in my mechanical room? They're showing radiant because they really focus on lower temperature emitters, and radiant's one of those. But that other slide that I had really emphasizes large BTU outputs with lowering water temperatures. So there's a lot of different products that we can assist with radiant to do more options than radiant. And I always get this wrong, but the flow of water is inside and the refrigerant's outside. Is that correct in the coaxial coil? Or was it reverse?
Yeah, the water flows on the inside and the refrigerant on the outside. Yep.
And how long is our coaxial coil, depending on the model?
Yeah, depending on the model, you know, if you were to straighten that thing out, it'd probably be about 12 to 15 feet long. So it's just great, you know, the way they design those coils, just again, it's to maximize efficiency and heat transfer.
Surface area.
Yep, the more surface area, the better the heat transfer, the more energy we can pull out of that refrigerant and put into the water, the more efficient that coil is going to be.
Yeah, think of that number right there, 200%. People are talking about cost of this, cost of that. 200% efficiency. You're getting paid to use this. You know, like you're saving that energy dollars and being comfortable while doing it. Harvesting energy from the air. I love that. That's a great statement. I like this chart. The green is showing your heat pump, your most efficient with refrigerant, right? And then you have your boost, because we just need a little something more outdoor temperature drops. And I think that's at like 20 degrees down to about 5, where we can play nice with assisting, whether it be, again, the onboard electric boiler. And if we should need more, well, the heat pump has done its job. For a small window of time, less than 2% where I live, you're going to be boiler only. So it's that staging or handshaking or playing nice with each other. It just gives you so many options. It's a great little option here.
Yeah, I kind
More
of
rare.
break this down. This slide is unique. Is that, you know, in the green area, that's the high efficiency zone. That's where you're seeing anywhere from 250, 400% efficiency. And then you get into the blue area, that's where we're doing some blending of the heat pump along with some assist from the electric boiler. And so that helps, you know, a bit lower efficiency, but you're still maintaining comfort. And then we're going to cut it off at 5 degrees or a selectable value by the contractor.
Absolutely.
We're talking heat pumps. I guess we're always talking about defrost, right? Want to talk about how we control that, or how we kind of switch over to electric, right? No hiccups.
Yeah, the beauty about defrost in a hydronic system is that we're, you know, in a forced air system, you know when the heat pump's going into defrost because the air coil is cooling down and you need backup.
That's right.
When a heat pump goes into defrost in a hydronic system, you don't even know it. I mean, you're not going to feel that temperature of the floor drop. We do rob some BTUs out of the floor to help that defrost, but what really ends up happening is that defrost, I've seen heat pumps that look like a block of ice defrost in 3 minutes because we're just using a warmer water temperature, bring that refrigerant, warm it up, get it back out there, defrost that coil. So our defrost cycles are shorter. They're still going to happen just because of your outdoor temperature, but we can ride through them a lot easier and a lot more seamless with the hydronic system. So
I haven't thought about that.
Yeah, I mean, if it's a situation where you really, you know, can't afford to rob too much heat out of the floor, we can use the electric elements. We can tell the unit, hey, I'm in defrost, bring on some elements to kind of charge the system and get that refrigerant warmed up. But most of the time, guys aren't even hooking up the defrost signal. They're just letting it ride, and it's again, you don't even notice it because we're talking radiant heat.
Makes sense.
You know, another, aspect of this slide, if, with the contractors on board here watching today, is that a lot of the pushback of electric heating systems that you do not have the ampacity in your electrical panel to handle the influx of electric boiler in there. And so if you still have an oil gas boiler, we can push you towards the energy efficiency sector of utilizing the air source heat pump down to its balance point. But rather than bringing on an electric boiler and electrical panel size, we're going to handshake it right over to that gas boiler, oil boiler for a nice seamless handshake off to it. And then when that temperature permits above that balance point of that heat pump, of course, it changes based on the heat loss of the home, which is very important, as you pointed out. It'll handshake it right back to the more efficient electric air to water system. So, don't just think that you got to be electric boiler with this too. Right. You can itch your customers towards air to water technology and high efficiency, and then shake it over to the gas boiler. Just an important aspect of selling this system too.
We've been talking a lot about giving people choices, right? Contractor has to be able to explain that, to be comfortable in that conversation. What I'm fearing is, and I'm hearing a lot of push, is from the homeowners to the contractor. And that's when I get involved. I've done some installs with some pretty talented hydronic guys, fuel, gas, East End. They said, hey, I got this job. I want you to try this. They trust me with all their other tentacles of their business, whether designing radiant, just setting up the systems. So they'll take my lead. And when he did the job, the first thing he said to me, that was so easy. And the biggest thing was venting. There was no venting for him. And in that respect of, he was doing an electric boiler. He hasn't done one of these. But just to see that change of his outlook was such a buy-in for me. And I can't say I talk about your products with most anyone I come encounter with. Yeah, so it's part of every day, pretty much. Good stuff. So the next slide here was, again, our selection. We had 32,000 BTU load. And looking at, well, a 15-degree day, well, maybe a 3.5 gallon flow, we're only going to get about 25.5. Now, correct me if I'm wrong, on this chart, this is solely the heat pump side?
Yeah, this is just heat pump performance. This is not adding the boiler at all.
Right. But look at the efficiencies, 198%. Or on a 35-degree day, 242. You know, anywhere between 35 and 47 degrees outside, you know, 250 to 240. It's amazing to see some of these numbers and efficiencies, and we're fighting against something that you're in a negative because you have cost of fuel leaving your building every time the thing is on, the appliance. It's amazing.
This is a standard heat pump, you know, this isn't considering maybe an inverter piece of equipment,
Right.
you know, where those numbers are gonna jump up.
Exactly. Yeah, about 30% increase on that.
Yeah, so that big, wow.
There's that 2 parts free energy, 1 part electricity, really to boost these numbers up. Neat stuff. Moving along here. Anything you want to add to that? Is something maybe on NOR Air? Here's a picture of what the unit looks like. I don't know what size that is, or, you know, what else would be needed.
Yeah, that's the heat cool. That's the heat cool version. So we can actually, we've got it set up that it can do chilled water too. So if you have those applications where, you know, you've got a fan coil unit, or they want to do a little bit of cooling with chilled water, you know, probably not so much in your area yet, but we're starting to see more people chill floors. You know, not necessarily bring them down to cold temperatures, but you take 10 degrees off of a floor temp, you can reduce your cooling load significantly.
Absolutely.
Right.
Sure.
Your AC system. You're not necessarily trying to cool the whole space, but starting to
Heat
see guys.
absorption.
Yeah, exactly.
Right.
You know,
Yeah,
in the next one thing I was going to mention, if you want to go one more ahead, you know, when you're sizing these things, and it's always good. You, like you're saying, we've got to size these properly. We got to do a good job. What we've noticed, especially with the variable speed units, where, you know, a guy says, "Oh, I only need a 4-ton," but they go with a 5-ton inverter, and you know, you notice if you jump up a ton size, you get a good boost in BTUs that
Right.
would cover you down to those colder days. And
Absolutely.
so now you're looking at not even needing a backup when you're down
Right.
to 15 degrees because you've got the BTUs. As it gets warmer outside, that thing can adjust itself to a 4-ton and match that output. Really, it becomes a pretty cool system. I mean,
Right.
the
If
system
we
that
jumped up to the 5-ton on a 15-degree day, there's 33,000, and it's still 170% efficient.
right.
That's heat pump solely.
Yeah. So there's, you know, a lot to think about there. I mean, but again, it's always good to size where you need it to be, but we can get, you know, as you get more into these and you get guys more comfort level, and using that new heat pump technology can really be a game changer to take it to the next level.
And there's
Yeah,
one more
Anthony.
thing.
Yeah, go ahead.
The total BTU load, how many zones is in that 32,000? And is it the chance that they're all calling at the same time, all the time? You know what I mean?
Right.
It's another variable of making people think a little deeper.
Now, looking at these numbers here, what is this based off of condenser wise as far as the SEER rating? You know, is this like a 13 SEER? You know, is it?
These were 16 SEER heat pumps that we did the testing with.
Perfect.
Yeah, and you know, we probably don't want to go down that rabbit hole too much, but SEER is a efficiency rating on a heat pump. Typically, when we're looking at heat pump, we focus on heat and HSPF. Yep.
Right.
But these are all, you know, the day of 13, 14 SEER is kind of going away. So everything that we've been focusing on 16 SEER and higher.
Anthony, if you go up a slide here, I just want to make a note on that NCFE model there. And just to keep guys in, think of, air to water systems and geothermal. Yep, that one right there. So geothermal systems, right? Well, this is a more affordable geothermal system. We looked at the numbers and we can see there's not much deltas between that and geothermal, but think about the air to water or air source heat pump becoming now your loop field. Your loop field is very expensive portion of the geothermal. There's systems at $35,000, $40,000 out there, 5-ton systems. Now here's a way to put that air source heat pump above ground, no loop field, and achieve near the numbers of the old geothermal systems, but you know, a 300% efficiency in there without the front end investment of well digging or taking out a loop field trench or whatnot. It's a viable option there for guys to consider doing heating and cooling for their clients' homes.
Very cool. One thing I have dealt with is green credits. It seems to be having less equipment outside the house is a benefit tax-wise or something like that for certain townships. So that's why the geo fields, it's not anything you see. It's not taking up ground space. But I do like that, the cheaper geothermal approach. They're expensive. They're not cheap, each well. All right, let's have some fun with this. The looks of the EZB, just think appliance. Everything you need is inside except for a keep fill. Keep fill? Is that what you call it? He's laughing.
Yeah.
So for those who don't know what a keep fill is, pressure reducing valve. So nice here, 5 to 20 kW elements. So depending on the vessel, you can buy up to 20 kW, 68,200 BTUs worth, which is a good portion of most any homes. When you do the math, when you do the heat loss, you know, those numbers sound small for most people when you look at or stand in front of people's homes. But do the math, you'd be amazed how much you can heat your neighbor's house with that much BTUs.
It's a fairly large home for us. You know, I just did a load calc on a 4,600 square foot home. Not brand new, but it was right there at 69,000.
Yeah. How many square?
It's 40. It was 4,600, which is really nice.
Lower the size of the equipment, become more competitive, close more jobs, play more golf.
Yeah, there you go. Yeah, I mean, yeah, this system is, you know, Europe, they kind of laugh at us Americans there. We build it on the job site, right? We solder as we go, we sweat as we go, and you know, you got to start thinking of appliances. Homeowners get the aesthetics of a product. They don't see what's behind the door. They don't care. All they want is comfort, efficiency,
out of my house,
reliability, safety, all those value key selling points that they wanted. And now they, you know, the labor is saved drastically. When we've done some numbers on this, we're saving 6 to 8, you know, hours of labor of piping this together, let alone the amount of time you have to go out to the supply store because you've got fittings, you know, to put this all together. So now you got
how many connections?
Yeah, connections. You got the convenience of putting this anywhere in a small package. So yeah, very cool unit, very cool control.
Yeah, we do have the new offering with the touchscreen as well, which we did a recent project and added the 4 zones to it. So there's some neat things even within each one of these products that we can discuss your application options, you know, flexibility. So there's that EZB 1024-1, and it's a 10 kW. And again, take 10 kW will cover our load for that project we did. And this is upwards of 180 degree water. So the electric boilers can do high temp. It's just that when we don't understand how to lowering water temperature, you're gonna get more efficiencies because electrical use and everything else becomes smaller, except for the emitters maybe, but neat stuff. Yeah, engineered to ease of installation and universal compatibility. I mean, that's it. You can build it or you can buy it, right? It's already engineered, done. It's a nice look of one installed. Again, low temperature, high temperature. Again, I took a couple of things from the earlier slide, yes to electric, and these are some of the things I highlighted. Quiet operation, no fan, no carbon monoxide, efficiency is 100% minimum, right? I mean, it's just no tune-ups. The labor savings, Dennis said, you know, boilers don't require primary, secondary. Not that you can't have it, it's not required. Those are time and talent parts of any install with high efficiency hydronics. We remove that. And again, no venting. No venting. Liability is gone. Neat stuff. Anything on that?
I mean, when you get into our electric boilers, our residential boilers, one big aspect of is the warranty. You're looking at a 20-year vessel or heat exchanger warranty followed with a 20-year element warranty. So that is the best in the industry, bar none. And there's 2-year parts warranty on that. But we stand behind that product there, that it's going to stand the test of time there, and we have the warranty to prove it.
Well, you were saying you had some 30-year-old systems and you're still offering repair parts.
Yep.
Were those boilers or some other product?
They're
Keep them
both.
alive.
Yeah.
We do our best to upsell. A lot of people get the idea that it's time to upgrade, but you know,
Right.
really it's such a simple system that they're pretty easy to keep going.
So when we switch from the EasyV or the Easy Boiler packaging, we go into individual offers depending on the KW loads, right? So we have the minis from 1 to 9. I'm giving you the max BTU output for the 9, as you can see. So that's the mini. We get into TS mid-size, and we get a little bigger. Again, on high side, 68240. That's like our package with that 20 kW. Now the kWs are done in banks of 5. Correct me if I'm wrong. So if we have 20, we have 4 or 5 kW elements. The first kW, the first thing.
Four
First-
stages.
Say again?
It's 4 stages, 4 or 5 kW elements.
Correct. But the first one has that modulation approach. And then we stage or we bank second stage, third, or fourth for the max BTU output. So that's that other stuff that I want people to realize. It's not a light switch. We do have some efficiencies in the way we turn on and turn off for more load requirements, and certainly shut them off when we're satisfying, or just trickle charging with that first bank or the first element. And now these elements, just so a little background, they're mostly from the bottom up. So serviceability, keep them off the ground, give yourself some clearance, 18, 20 inches. And, you know, there's some nice things about the elements themselves. They're not traditional off the shelf. They're robust, they're longevity built for, you know, a lot of service. But in a pinch, you could do something in the middle of the night to get people up and running. So there's some nice things about that. Play nice with others.
Yeah, it's a low watt density element. So if you were to put one of our 4.5 kW or 5 kW elements next to a water heater element, it's longer, it has more surface area. So we spread those watts on a bigger surface area that just leads itself to a longer service life.
Gotcha. Very cool.
That question. Got a good question here asking about how do boilers hold up in hard water conditions?
Well, you got to remember this is a closed loop system. So anytime, you know, we've got some requirements for the hardness and, you know, mineral content in the water. So we want, you know, just like you would do in a gas boiler system, you know, you want to treat that water, put a, you know, flush, descale if it's a retrofit, stabilizer, glycol. You know, typically we're not introducing new water all the time into the boiler. So it's, if somebody inadvertently used this as a domestic hot water heater, no, it would not hold up very long because oxygen in the water, things like that are gonna affect it. So the closed loop system, we want to try to put the best, cleanest water we can right from the get-go.
Correct me if I'm wrong. I'm thinking of the construction. You're an open vessel. You have large water pathways as opposed to maybe most modern condensing boilers. A lot of surface area, but tight water pathways. And that's where they get that foul factor.
Right.
And I think you have a lot more protection in just in construction, the way it's designed. The elements, yeah, I guess they can be affected by, that's again, a lot of fresh water. I mean, it's a closed loop system. So depending on your water quality, we see it here on Long Island, people who say, oh, New York has good water, you know, but there's hardness. There's, you know, there's a lot of things in our water that we need to be aware of. Because it short lifes, a lot of really expensive equipment.
Right.
And then people start pointing fingers.
You know, typically the worst thing that can happen if we do have a lot of hardness in the water, it'll start to stick to the elements, and you get some kettling noise, or you'll get a percolating noise. Like sometimes you hear it on a electric water heater. Elements can be removed and cleaned if that's the case. So it's not like it's going to destroy the boiler or anything. It's just that for longevity's sake, we always want to try to treat that water in the system the best we can.
Is this line going to change for you guys? I think you guys are going to maybe shrink it or put some sizes in the middle.
It's changing, it's evolving right now, and it's a good question. You know, the mini boiler now has just been certified here, and the mini boiler is available in that 1 to 9 kW as they have slated here. But now we're utilizing 2 solid state relays or SCR controls for modulation and provide much truer modulation. But we're going to make it available in 1 kW up to 18 kW. So same size frame in width and in depth, and the height of it just changes by about 4 inches. But so basically, it same package, but can give us about 60,000 BTU capability. And then the mid-size units are going to go from 10 down or up to 36 kW. We have 4 element slots in there, so 4 times 9, 36. TS standard that you're showing there here has 6 slots. That'll be a 54 kW boiler. And then our commercial series is 9 slots. That'll be 81 kW. So those it's going to give way to just much more growth of the product line, because we're not really adding a lot of very minor cost improvement in there. There's no more steel really to be added to it. So it's just a higher kW offering there in the same package. But yeah, we're excited about where that's going, and we might bring some other elements to this to bring in a package boiler like the Easy B has an option to have onboard pump, maybe zone controls built in, zone valves, pumps. There's going to be a lot of evolution of this product here in short term, probably within a year or so.
Very cool. I know we're going to install one in our Energy Learning Center. We're going to have live fire. We're going to isolate and take over a snow melt. So we'll have it up in front, you know, out in front. People will see it, show them the controls, and certainly have the ability to live fire, which would be great. It's soon to come. And then, of course, you go into your industrial. This is over 1 million BTUs. So to have a project on a scale and using electric, tell me about that. Why? What is it about this? Is it a handshake with utility? Like, you know, what drives someone to this application?
Well, I think it's, you know, a lot of things. You know, large electric boilers have it is a bit of a niche market, but there's a lot of niches. There's a lot of places. You know, you mentioned snow melt. You know, you look at some areas of the country where, you know, what we're hearing is insurance companies are giving huge breaks if you have snow melt on your sidewalks and your parking lots and things like that. A company might look at that and say, well, you know, we're in an area of the country, we might get 3 inches of snow a year, or we might get 3 feet. It's kind of hit or miss.
Buffalo.
You know, are we going to put in a 1 million BTU gas boiler and the venting and everything that's needed for that gas boiler to do snow melt, when we could do electric, probably a lot cheaper upfront cost. Yeah, it might cost us a little bit more to run it if you know, if it's an energy cost comparison, but the amount of time we run it is going to be, I mean, 1 year you might not even run it if you don't get a lot of snow, or it might run for 5-6 hours. Another year it might run a little bit more. So, you know, we've seen that quite a bit, snow melt, or just really large radiant projects, you know, 20-30,000 square foot buildings where they did floor heat and they want to use an electric boiler as the source for heat.
Application.
Yeah.
That's made me a believer, is just seeing different applications. And you brought something up, and I don't know where this is in the world and the country, but I saw the need to snow melt an off-ramp on the highway.
Right.
And thinking about that remote building, who's going to be out there, you know, with gas service or oil tanks or propane tanks? And now you have the ability to run electric. So I kind of see that. Neat stuff.
Yeah, I think this industrial boiler too is, you know, you're in New York, you got the epicenter of government, educational buildings, institutional buildings, and they're the first that's going down this decarbonization, beneficial electrification route. As you guys know, local law 97 there is going to take root here, and that's going to affect 50,000 buildings there that are 7 stories and less that must go some form of electric heating technology. Will it be heat pumps? Maybe. There's limitations. It's going to be these electric boilers, and so we can twin these up. We can go lead leg on them, but some of these buildings might do like a time of use, dual fuel type of applications where they're going to run the electric boiler as their primary heat, but we're going to handshake it right over to their existing gas or oil boiler when peak critical pricing comes into the market, that they can handshake it over and be seamless in their operation and providing heat to the building. So,
love it.
Big time applications with this product. We're excited. We're going to maybe expand this out to 2 to 4 million BTUs over the course of a couple of years, because we know we need to be a little bit bigger pocket with it, but we can get there in 2 million BTUs or more with, you know, other staging controls.
It's just after 9. I thank you for your time. I know you guys are up early, and one of the questions I had, and I forgot to ask, because you guys just came back from Atlanta, Georgia. Is there a lot of excitement? How is your booth? Any competitors? Something that you've seen change in the wind? All the above?
Yeah, it was a great show. I mean, of course, Atlanta is one that's not a traditional heating market. You get ASHRAE, AHRI. And but yeah, we had a great show. We had, you know, obviously we had a great following with our rep market, but we're seeing some contractors and wholesalers coming to the booth. We've seen engineers coming in as they're preparing their business, and that's the smart thing, is they're preparing their business for this beneficial electrification growth, decarbonization, decasification growth. They're reading the tea leaves, and the smart ones are positioning themselves to be able to understand this technology in order to provide these services for the downstream client or homeowner. So it's a exciting time, and we're excited about you know, seeing the excitement from our customer base.
Well, I'm going to say thank you both. It's early for everybody, but especially for you. Thank you for your time, your support as well, and we hope to see you guys again soon. I did have this last slide for you, Dean, and this is where anyone on here, how do we get in touch with Electro? Great website, brand new look, a little modern, fresh, but to have a monthly boost, I guess, is it monthly? You guys are offering webinars?
Actually, we do, yeah, two a month. Every 2 months we do a webinar, yeah.
So February 23rd, it's Central Time, so 11 o'clock Eastern. Get registered, and then show your support to a great company that hopefully will keep giving more. Any questions? Otherwise, Rick, you've been doing a great job.
Yeah, questions have been great. You know, we did have I was waiting for this. I thought we would have got this first thing, before we even started was, current rebates. Are we seeing different utilities, offering rebates around our products? The short answer is yes. Depends on where we are, but.
Right. What part of the country,
Yeah.
what utility. We have different utilities just in New York State, from Long Island to city to upstate New York. And they all seem to have a little difference or a partnership only of two. One seems to be isolated, one Long Island here. But
Yeah, I mean, I would honestly say if you plan on going with a product like this, check your local utility, reach out to them, because things, we find that things changing all the time as far as rebates go. We're understanding that maybe there's a list of rebates out there, but they have these custom rebates, that we're able to kind of fit into when there is not a rebate. So most of the time there is something that they'll work with. So.
Yeah, I mean, some of the utility companies are offering HSPF, if it meets a certain criteria of HSPF on a heat pump, I should say, qualify that, then it could qualify for rebates. Now, Electro doesn't make the air source heat pump. We match with it. And so there's not a unitary match to our indoor unit, and therefore it may not qualify for a match from AHRI. However, they're kind of going away from that quality control and saying, all right, we're going to go under the merits of the heat pump itself. If it reaches a certain HSPF rating, that's going to be good enough for us that, hey, this product can do what it's supposed to do in saving energy, and we'll give rebates to that. We see some parts of the country that give rebates per kW of electric heating in there to help guide that customer as a viable solution.
explain that a little deeper. Because I'm using KWs, I'm going to get rewarded.
Yeah, I mean, not necessarily kilowatt hours being used, but more so KW to help offset the front end cost of electric heating equipment, be it boilers. We see in Minnesota, we see, $20 a KW. It helps. It doesn't help offset the whole entire load, but it helps, give a little bit of kickback rebate there. So we're seeing a little bit of that trickle in different parts of the country.
Interesting. Anything else coming your way?
Nope, we're looking good. A lot of thank yous. Appreciate the support.
We hope to do this again soon. I think this was a great little volley. Thank you guys for everything you've done. If there's anything else, please let us know.
All right, thanks, guys.
Join us, guys.
Guys, have a great day.
Yeah, you guys do. Take care.
Take care, all.
Thank you, guys.
Yep, bye.